just to make sure everybody's on the right track, I'm going to do the first problem. I'll give you a couple more minutes to finish out the second one. So this problem, we know it's normal.
Yeah.
Close enough, right? Approximately. So then, even if I just take a single, in this case, person, I can still draw that curve. I got the mean is going to be 2.9. I want more than 3. Get in there. So now, by this point, this is that classic z-score problem. So we need to have this just become second nature because we're going to start messing with this thing. So now I change that to a z-score. I forget what I think you guys got 0.32. Is that right? Do that work, you get 0.32. When we look up 0.32, you get 0.6 something.
6255.
6255. And of course, your picture's telling you, oh shit, I didn't get the answer yet. So you got to do 1 minus that. $3,745. Is that all right? You guys, the other one, right? So that's the old news problem. So here, the very first thing I do when I see, so here's the trigger. When I see it, I take in a sample, and the question is asking about the sample mean. So now I want to compare a sample to all the other samples, their means. So that's why I need to change the standard deviation. So the very first thing I do is just take a second to do that. Where'd it go? 0.31 divided by what?
Square root of 38.
Square root of 38. And you get something or other.
0.0502.
I like it. 0.2, right? 0.2.
Yes.
You could just stop at 0.50, that's fine. But when it gets even smaller, it's better in general to go further out. Now, all the steps are the same as the first problem, which is kind of funny. When you think about how long it took me to explain the idea, and you're like, funny, that's a word. The idea is really kind of complicated. It does eventually make sense. The actual effect it has is minuscule. I'm done with the effect. So now I still draw my normal curve. I put the mean in the middle again. I put 3 over there, make a z-score, but now when I go to make a z-score, I better divide by 0.0502. Now if you divide by 0.5, you get 2. Does that change for 0.0502? 1.992. 1.992? Alright. So you either got 2 if you use 0.50, you got 2, or you got 1.99 if you used 0.502. I like it. So so depending on which one of those, it'll be a little tiny bit different. So if you got 2, that would be 9772 down here. Get in there. And then this would have been 0.228. If you use 1.99, that'll be where'd it go? 1.99, get over there. 9817, I think. Am I looking at it right? No. 9767, right?
9772.
No, that's for the 2.
Okay, 9767.
Yeah, for 199 would have been 9767, and then this would have been 0.0233. So 0228 and 0233 are pretty damn close. I like it. So now let me push this problem. Is everybody cool with that problem? Same exact steps. You just change the standard deviation because it's the wrong one. If I did find, say there's a group of 38 women, they had wandered into this warehouse or this area where they were experimenting with new radiation. So I watch way too many freaking superhero movies, but and they all wandered out and were like, oh shit, let's test these. What happened to you guys? You know, like, we feel great. What are you talking about? And their bone density comes out, the average bone density is more than 3. Is that evidence that something changed with their bone density? How likely is it to find a group of 38 women that have more than 3 bone density. A little over 2% chance. So if I do find that, especially when they all have a similar experience that ties them together, then I'm like, something happened. Now, it would be great if I knew what their bone density was before, but in this case, let's say I don't, right? These women never got their bone density. So here I just know that is really unlikely for a random group of 38 women to have a bone density more than 3. So I feel pretty good that radiation maybe caused an increase in the bone density. Maybe I just found a cure for osteo, whatever the right thing after that is, porosis. All right, showing off my amazing medical knowledge. I got the osteo right. All right, are you guys semi with me? I mean, this is the real power of what we're learning finally coming to bear some fruit. We can test claims. We can go in and see, does this look like it's different from what's normal? And then we can get a little deeper into what might be causing this, right? Okay, keep going. I don't know. I think some of you guys are done with this one, but finish this up a little bit. I'll give you a couple more minutes. Can I actually write down the essay?